this week we are going to start Chapter 8, where we'll talk all about memory. And so with our usual course of events, we're going to start with the definition. And so memory refers to the processes involved in retaining, retrieving, and using information about stimuli, images, events, ideas, and skills after the original information is no longer present. So that is quite the mouthful, but we're talking about processes, stuff that your brain is doing, where it's holding on to or making use of information, and that information is going to be stimuli from our environment, things that are within our minds, thoughts, events, things like that. And all of those are things that we can manipulate or retrieve or make use of after that original information isn't present any longer. So after an event has passed, we can think back on it or remember it using the processes involved in memory. And so throughout this chapter, we're going to be talking about memory using the information processing approach. And now this might sound familiar because we've actually already talked about this approach way back in Chapter 1 when we were talking about the emergence of the cognitive perspective. And we had talked about a revival of the cognitive perspective back in the 1950s when computers were first becoming a thing. And we'll find that a lot of the terminology and a lot of the analogies that we use when talking about memory are going to harken back to computers and things like that. So if you start seeing some parallels, that's going to be why. Our way of thinking about memory is going to link very heavily back to our cognitive approach that we talked about earlier on. And so on that note, we're going to talk about memory as something that can be viewed as a processing system. It's going to encode, store, and retrieve information. And those terms, encoding, storage, and retrieval, are going to be a constant thing that we talk about throughout this chapter. And for the basics of it, let's give them a quick definition because we're going to throw these words around quite a bit in the coming up slides. So first off, encoding is when we're translating information into a neural code so that it can be stored for later use. This is going to be like a translation where we're taking information from one form and we're going to turn it into something else that we can use. So the textbook uses, of course, computer terms and metaphors to help us understand this. And they talk about encoding as in you're typing on a keyboard. And so you're taking the buttons that you're pushing on the keyboard and the computer turns it into a document that's full of words. So it's going to take each button press and add that to the document, translating it from a mechanical push button to something visual that we can see on the screen that is a digital stored symbol that we can use for later. It has been encoded for something we can use within that computer. For our next thing, we're going to talk about storage, which is the process by which information is retained over time. It's where you are storing information across long periods of time for later use. And if we bring that computer analogy back, our storage is our hard drive. It's the place where we're keeping that information for later use. And then retrieval is when we start pulling information back out of your mind for use. So again, our computer, if you have a file saved on your hard drive and you want to open it and look at it at a later date, you can retrieve that information by pulling it off of the hard drive so that you can see it again. And the computer analogies aren't perfect, but they'll do for now. And so when we're talking about this process of encoding and retrieving and storing, we're also going to be talking about all of the processes that fall in between, or all of the structures, theoretical structures, not necessarily specific parts of the brain, but these different structures or components are part of a model. And we've stuck together these components and those processes involved in what's called the three-component model. And as you can imagine, the model is going to consist of three different components. The first here is our sensory memory, our sensory registers. Both can be used interchangeably. Here we have our short-term or working memory, and we'll talk more about that when we get into the chunks where we discuss short-term and working memory. And then the third component being our long-term memory. And this diagram here is going to come up over and over and over again during this lecture, so we'll get pretty familiar with it. So right now it looks like a lot of stuff going on, but by the end of the class it'll make a little bit more sense. But I will point out here that we can see our encoding, where we're translating information. We can see encoding again and retrieval, so things are already maybe starting to slip into place. But of course, as per usual, we've given ourselves a roadmap for the lecture, and now we're going to talk about each of these components individually. Starting, of course, with sensory memory. And sensory memory is going to be how we're getting information from our senses. So our sensory memory briefly holds sensory information. And in our diagram, we had also called it our sensory registers. And so sensory registers are the subsystem of our sensory memory, basically the functional part of our sensory memory. And that's also going to be a part of initial information processing. And so we're going to look at some examples that'll help make some of this a little bit clearer. And so if we're talking about our sensory registers, we're going to focus on two of the most easy to talk about sensory registers. The first is our iconic store, and these are holding on to visual information. So the iconic store is our visual sensory register, and this is going to last just a fraction of a second, but it's what happens when you're basically walking along and something catches the corner of your eye and you halt for just a second and you go, wait, what did I just see? And in your head you can almost play back the thing that just briefly flashed across your eyes to judge if you should look again. That's your iconic store. It's sort of a buffer for your visual information where you can kind of double check something that maybe you saw but weren't paying attention to. We can bring our attention back into the frame here. So it gives us a chance to pay attention to something that we might have missed the first time. But because it's such a quick thing, it only lasts a fraction of a second, you have to shift your attention very quickly or else that information is lost. Our next type of sensory register is the echoic store. And this is the one that holds auditory information. So our echoic store is going to be our auditory sensory register. It's holding on to our auditory information. And this one lasts a little bit longer. So this is going to last about 2 seconds. So quite a bit longer than a fraction of a second. And again, this is, say you're walking through a crowd and something kind of catches your attention. Maybe you hear your name and you're like, wait a second, what was that I was hearing? And you can kind of play back what you had just heard. You can play back about 2 seconds worth to figure out if what you kind of heard is worth paying attention to now. So a lot of what we're using our sensory registers for is deciding to bring our attention to something that we didn't necessarily pay attention to the first time round. And so if we're talking about something being a fraction of a second or 2 seconds in duration, you might be wondering, well, how are you figuring that out? How are you determining how long we have that information available to us? And it's a little bit easier for us to measure the capacity of our iconic sensory register, so the things that we can see. So we're going to talk about an experiment where we did just that. And so this was done by Sperling back in the 1960s. Again, I don't really care about the name or the date, but it's neat to know that this was something that we've been studying for quite some time. And during this experiment, they had an array of letters, just like this blue box down in the corner here, and you had sort of rows with a bunch of letters across. And so that array of letters could be flashed very quickly on the screen. Not long enough for you to look at and stare at and memorize all the letters, but just long enough that your iconic sensory register, your iconic store, could pick up on it. Then we would have the participants report as many of the letters as they possibly could. And they'd use either a whole or a partial report method. And I'm going to show you what that means on the next slide here. And so a whole report would be, tell me what you saw from all of the different rows of letters that we gave you. And so the person could pick from the first or the second or the third row, as many as they could remember. They gave them everything. A partial report is when they would ask them for just one line. So they'd have to remember the whole thing until they were told which line to remember. And in this case, they would use something like a tone to tell them which line that they wanted them to recall. So in this case, they'd use a high pitch, a medium pitch, or a low pitch. If you heard the high pitch, report the first line, medium the middle one, and low the bottom line. And here, if people were given that tone relatively quickly, they could then ignore or forget the bottom two rows because they only have to pay attention to the top row. So that tone lets us know what part of our iconic store is important, so we can ignore the rest of it. So you'd actually do pretty good if you were given that cue of a tone of which line to remember right off the bat. However, down here we have a delayed partial report. And this is, you show them the whole image, you wait just a second or two, because we just need that fraction of a second to get everything out of our iconic store. And then if we wait just a fraction of a second and then play this tone, we could tell them the top, the middle, or the bottom row. But because we delayed, that information's no longer kept in their iconic store, and they would struggle to recall more than maybe one or two of the letters. Whereas if you do it immediately, if you don't have that information leave their iconic store, they could remember maybe the whole row. So the length of this delay, and in the experiment you can manipulate the length of that delay, you could figure out pretty precisely how long things last in our iconic store based on how quickly they went from remembering everything in the row to only a couple of things in the row. And so that's how we know that our iconic store will only hold that information for a fraction of a second. And you could set up a similar experiment using an echoic store, using our hearing, but the visual one's pretty nice to talk about and to look at, so we'll stick with one example for now. All right, so that is our sensory registers. And we had talked a little bit about how those sensory registers help us with attention, knowing what we should pay attention to or not, to bring that into our consciousness. So if we want to pay attention to that and then maybe retain some of that information, and we'll notice that encoding would be involved in taking that sensory information and bringing it to our next section we're going to talk about, our next component, which is going to be our short-term memory.